Automation failures usually give us a static canvas and a final error, but not the state transition that broke. Teams guess, change multiple nodes, and retry against production. PatchWitness turns one failed execution into a repair you can prove. I import a workflow graph and its execution trace. Before any model call, PatchWitness removes credential-shaped values, maps side-affecting nodes, and builds a deterministic baseline. Original secrets never reach the model. This run begins with a message, downloads a voice file, transcribes it, classifies the request, and fails on reply. The reconstructed branch shows that the conversation identifier disappeared across the binary data boundary. This is a broken state contract, not a messaging credential problem. PatchWitness proposes the smallest repair: restore the immutable conversation identifier from the trigger immediately before delivery. It preserves node names and connections, and marks outbound actions dry run until replay passes. 4 counterfactual checks verify the branch. Required state, side effect isolation, and minimal patch surface. The result is a portable receipt a teammate, CI system, or auditor can inspect. I built PatchWitness with Codex during OpenAI Build Week. Codex helped turn recurring automation incidents into the verifier, privacy boundary, responsive product, tests, documentation, and public deployment. At runtime, GPT-5.6 SOL uses medium reasoning effort and structured outputs to produce causal findings, a minimal repair, and replay assertions. The deterministic verifier remains a safe second opinion and fallback. PatchWitness, failure, repair, proof. Because an automation is not fixed until the evidence agrees.